Hi, everybody. Very good evening to the guys who are attending this webinar from India, and good morning to everybody joining us from US. My name is Vishal, and welcome to this webinar on Java 8, and well, very specifically about the new features which are added in Java 8. Why are we even having this webinar at the first place? I mean, it is not just for the sake of academic interest, right? That we are talking about a new course altogether. Or why are we not talking about Java? Why are we saying Java 8 specifically and new features and all? So what exactly are we trying to achieve? What exactly is the objective of this entire course, which is launched on Java 8? I would like to talk about those aspects, and as usual, it always happens with the Edureka webinars that we'll walk the talk. So we'll try to do some sort of hands-on at the end of the webinar itself. Well, before I come to the objectives and all, you must just be wondering who's this guy Vishal and all. So let me just introduce myself very quickly. You know my name, Vishal, already. Uh, I'm having now, I think, almost more than 12 years of experience. And out of that, since last almost 5 years plus, I am working in big data domain altogether. When I say big data, it is not just Hadoop, like some of you or many of you, my journey also started in that way back in 2010 when it was in the starting stage. And now I find myself doing more of the work wherein if some of you have heard about it, it is called lambda architecture. So lambda architecture implementation, and in that process, it is a mixed bag of different technologies, languages, and all, but primarily into Java thing. Before that, also it was the same platform. Core Java is my strength. Coming to the place wherein, in terms of the domain, so it's primarily into the finance domain and retail. There were a few projects for telecom domain which I did, and I think for healthcare domain as well, but they are like very few as compared to the others. So I think, yeah, that's good enough to get started from my introduction part of it. And are we guys good to go? I hope all of you are able to hear right now, right? There are few objectives which we definitely want to achieve at the end of this webinar. And first thing first, why is even a webinar on a language which is so much known, right? Which is so much common, is even happening right now, right? So we'll have to go to the point wherein why even Java 8 is coming into picture. I mean, it's not the first release of Java, or it's not the last release of Java which we are talking about, but why specifically about this release? We never saw any course on Java 7 or Java 6 or something, right? So some of the things, right? And then, well, that will create the ground, okay, for the features which have been introduced. I don't call them as features because features typically mean that a different way of doing the thing, right? That's what typically may mean by that. But here we are talking about the new concepts themselves which are being introduced in Java. Java itself is undergoing through some paradigm changes altogether. The way it works, the way, or the way you tend to write your code itself, right? So your mindset itself is going to change. And in order to do that, right, so we'll talk about it. And if the time permits, though in the actual course, in the actual classes, we try to evolve the solution right from 0 1. But here, in the interest of time, I will I'll give you a problem statement. We'll try to discuss with it, and we'll just see how exactly the solution evolves, and then eventually I'll short circuit it to the way it is implemented in Java 8. Okay, so that you get the essence of the things, and you get to know what exactly are the benefits. And one very quick example should really help all of you. Looks like a good coverage, looks like a good uses of your 1 hour dedicated time. I hope so. It should be, right? So, with that approach, with that objective in mind, I'm just continuing forward. So guys, uh, a quick timeline of Java, right? This starts, I mean, again, it is not even right now pointing out all of the versions of Java. It is just pointing out the main or milestone versions of Java itself, right? Java 1, 2, 5, 7, 8, and things like that. So this entire webinar and this audience itself is is the proof that there are people who are working from the different points in this timeline. So guys, when let's even talk about this Java 1.0, and again, I'm not talking from the history bits perspective. It's all about the way this itself will drive the discussion in terms of the drivers of the change, why exactly it is, again, it is changing. So Java 1.0, when it was introduced, it was one of the very few initial programming languages which were supporting this entire object, or which were supporting this entire paradigm of object oriented programming altogether. Everything is a class, and then it's a different programming paradigm which was introduced way back when Java 1.0 was released. Beginnings were humble. There were very few classes altogether. Thing is, it was quite slow at that point of time. Nobody even thought that, probably it will, again, it would be one of the languages which will emerge, and probably it will die out altogether because of the sheer performance things, right? It had to compete with C, simple C, C++, and all. So it was definitely slow, yes, no doubt about it. And at that point of time, even creation of the applets, not sure how many of you, because as your experience itself tells, right, many of you have joined from Java 6, but ask the guys, I think probably Geeta and somebody else might tell you that applets were the big things even by Java 2 itself, right? So those were some of the things which were there in 1.0. Well, good thing were like your concurrency support and other things were present right from day one itself. Okay, with by the time your Java version 2.0 got released, it got really faster, basically the performance improvement part. So the focus was basically to make your, or to fix your shop, right, to get your basics right. Forget about features. More than features, it is about your performance, and it should be running across, you're talking about across platforms, and all extendability and other aspects come into picture. And then suddenly people started talking about J2EE, J2ME, J2SE. These are the different flavors of Java which became popular altogether, and it eventually became very popular language for most of the web-based applications or web-based projects altogether, right? That was the time wherein this, this bubble, dot-com bubble and all started inflating and all that stuff. So that these are the way it went through. By the time Java 5.0 got released, okay, it was very powerful. There were major syntactical changes which went through. So earlier things were really clunky, but it was then 5.0 was, or I would say all 5.x kind of, releases basically focus to make it more developer friendly. You at the end of the day, who is actually working on this language, right? So it's basically more about developer friendly thing, write write more and less sort of thing, right? And eventually it became the choice for enterprise. This was the marker version from which onwards basically it, or like you have some certain standards, right? When you talk about search, you think about Google, right? When you talk about enterprise language and all, you think about Java nowadays, right? So but these things started taking their shape around this version onwards. Then there were multiple versions, Java 6.x and all, again not going into that. They were regular off the factory releases altogether. Then Java 7. Java 7 itself had undergone, again, if you look at it, whatever changes which we have mentioned here, be it introduction of the generics, introduction of the iterators. When I say concurrency support, it doesn't mean that concurrency was introduced here. It simply means that the improvement of the concurrency support in terms of fork join pool, if you guys have used it, right? So it is much easier as compared to, explicitly managing all of your threads and all. And then JS integration, Nashon, JS engine integration and all that stuff started happening there. That was again, in terms of very it was quite a feature rich release. It changed the way people used to write their code in terms of the syntaxes, not in terms of the programming methodology itself. Okay, so this was up to 7. Now let us talk about Java 8.x or 8.0, which is the current version altogether. This is the version which changed the world of Java itself, which changed the way you write the program, or the with the mentality which you typically hold while writing a program. So here Java claims, again, I'm very honest, I'm not saying Java supports. Java claims that it supports functional programming. By that, what I mean to say is now you can do functional programming. Most of its aspects are can easily be done now in Java 8.0. So that's a big change. I'm not sure how many of you have done the functional programming part of it, but uh, just to tell you why such a big fuss about it, it's all about we are living in the age of big data, right? Forget about big data. We are basically living in the age of distributed processing and all. And functional programming style is much better, or much better suited for these kind of share nothing architecture kind of programs as compared to the the kind of programs which you write via object oriented programming. So Java itself was kind of finding itself in a very clunky position, wherein, or I would not say that it was irrelevant, but it was not very friendly for while doing the development for kind of, let's say, certain kind of applications altogether, specifically when it comes to the distributed applications altogether. So this was one of the things. Then exception handling itself got changed. So when I say exception handling, again, we are not talking about the new types of exceptions being involved and all. I'm 100% sure in this entire audience, all of you who are hearing, and if you have ever done the programming in Java, all of you would have definitely faced null pointer exception. Am I right? Or is there anybody who can claim that I have never ever faced it? Because either you are the best or you have really not programmed, right? So almost everybody would have experienced it, right? So this language brings a concept called optionals. I will talk about them, and I'll talk about the different features of Java 8 in a bit more detail, right? But here with optionals, basically null pointers are one of the most common exceptions, but they bring your entire application to its knees altogether. So they have really improved it, the handling of exceptions via optionals. It has changed drastically altogether. uh, Streams got introduced. Now streams, um, so has anybody heard about streams? Again, I'm not talking about the buffered stream and all that stuff. No, I'm not talking about that. I'm talking about the data which is coming via stream. So for example, if you have worked on Linux and all, you can use a cat command, right? So you can say cat a certain file, right? And when you say cat certain file, what happens is you get the content of the file, right? And then let's say you say cat file xyz, and then pipe operator, and then say something else, grep Vishal, or grep Edureka or something, right? So what is your intention right now? Your intention is to look at the content of the file, and then pipe operator means whatever is the output, take it, right? See, this is the important thing. Whatever is the output of the command cat, that becomes the input for the another program or another command called grep, right? So whatever is happening here, the way your data is proceeding from one command to the other, that mechanism is called streams. It is basically going via stream altogether. And most of the stream real-time applications and all, I think if you have done a bit of googling, you will find that most of the real-time big data analytics systems, basically they leverage quite a lot on streams. Specifically, if you talk about Storm, if you talk about Spark and all, they use it very heavily. But that's where there was another bottleneck, right? In terms of suitability. Java, well, you're talking about supporting. Yes, it was supporting, but was it really easy and all? No. And stream, along with, there is something called lambda, which I have not talked about right now. I will talk about it when I'll go to that when I'll go to that new feature slide. So streams, along with the introduction of lambdas, have become way powerful. So much so that your hundreds of lines of code can be written only in 5 lines or 10 lines now in Java. And I'm not talking about Java versus some other language. No, I'm talking about Java 7 versus Java 8. Simple as that. And then there is a new date and time API which has been which is now introduced in Java. And this date and time API, well, it is not just another date and time API. I'm sure most of you who are practically working in Java, you know what are the challenges which come along with date and time. And most of the times you end up using Joda time, aren't you? Right, at least I'm using, and many of my colleagues use it, and that's what we keep on doing that. But Java has taken that step as well, and they have improved it. The biggest thing, I mean, it's all about spilling the beans, but yes, the biggest change which I would say in one word is, now your date and time APIs are immutable. They're not the mutable ones. And this decision is good, it makes it thread safe, good. But it is not just that they have made it immutable, they are following a certain methodology of functional programming. So I'll try to cover that part also very quickly in this webinar. So these are few of the changes. Just by looking or just by hearing me for last few seconds, you might have realized that functional programming support, the support for streams, the support for optionals, well, if not much, but and then the support for lambdas. Okay, lambdas are like your anonymous programs. You cannot write any anonymous program at all in Java as of now, right? Up to Java 7. I'm not talking about anonymous classes. I'm saying just some piece of code which you just wrote, which is kind of in a very offensive way of saying, it is kind of an orphan code, right? You can still write it, and it is a big tool of miniaturization of your entire code altogether. So we'll talk about that. But just by looking at it itself, you might find that yes, there are some radical changes which are on the way. Now, after this slide, my focus is going to be, just a second, my focus is right now about, I just gave you the idea about what is on the way. But before I actually get into that, right, first we should even understand, why are these changes even coming, right? And what are the actual drivers? Is it just that, writing program became a bit longer process? Are we just talking about that? Or are there some other changes, or are there some other reasons, right? Because that will really help you to understand, like, when you are attending this webinar, apart from the academic interest, is this something which is relevant to you or not? Right, it's not a sales pitch wherein we are trying to sell some course or something. We are trying to share the knowledge at this point of time, and we are trying to share that what exactly are the better ways of doing the things, right? So this is going to be my objective for the coming slides, right? In between, I think there was a comment from Shubham wherein he says filter method and limit methods, etc. used. Yes, so these are the different methods of stream API, Shubham. Okay, which are introduced by Java 8. Okay, so we cover them in quite a lot of details in the actual course there. And so now coming to the changes of the main drivers behind these changes which are happening. So just by looking at the previous slide itself, of course, and by your experience also, you are quite clear that Java was kind of a mature language from day one. It was a well-designed language which was supposed to be the main tool for your object-oriented programming altogether. It had the support for many inbuilt libraries right from day one itself, and the concurrency support. So all of these things were there. It, But the main game changer, I would say, was the decision to convert your code to the bytecode. So yeah, so I was at the point wherein I was just telling you that yes, supports were there, and the biggest game changer, as all of us know, is the point that wherein you have decided that yes, it will be a bytecode and it will run across platform. That is something which made it way powerful. Days were good, and then eventually other languages started emulating it. Well guys, that's where a unique thing happened. Okay, so the unique thing is eventually it happens across different languages, across different features and all. So people found that the the best thing about Java is, so the biggest thing or the biggest advantage for Java, as I just mentioned, is it can convert it to the bytecode and can run across the platform. People found it very interesting, and that's where eventually JVM itself became an asset, because that's the reason, that's the place wherein your bytecode is actually converted to the actual executable. I mean, your program is run altogether, right? So that's where people started investing more time. There were a lot of contributions which happened eventually, so much so that there was a situation, or there is a situation, wherein JVM becomes more precious asset than the Java language itself. Okay, so where are we trying to, or what is the point which I'm trying to bring here? Okay, so the point which I'm trying to bring is on slide number 5. Okay, so times started changing. Again, I'm not reading through the slide, guys. I'm just talking about the flow, and eventually I will refer the points also. Okay, so eventually what happened is people found that if my language can convert its code to the byte code, then I can run my program just like Java anywhere. So eventually you saw many languages emerging which started converting their executables into the bytecode just like Java, and then you run your program anywhere and you make it callable from Java, and or Java becomes callable from your program. Simple as that, right? And hence you saw the languages like Scala, like Groovy. There are other languages as well, right? Which started emerging, and they started beating Java in its own playground, in its own playground, because these languages had the advantage of starting late. These languages had the I would say the advantage of seeing what went good, what didn't go as good, and they improved. Talk about Scala. It was a serious threat. It is still a serious threat for Java. Yeah, no, I'm not sure how many of you have heard, but there is an entire version of Hadoop which is being written in Scala right now, right? Your Spark comes completely written in Scala altogether, right? So there were reasons. It's not like somebody thought that okay, I will write this particular framework completely in Scala or Groovy, or as Shubham and others are also mentioning like Jython, etc., etc., and then it will do. No, they gave the advantage of user friendliness of a scripting language, yet the yet being as powerful as Java. Okay, those were the serious threats. It started as a very small thing, but then it's like your snowballing effect altogether, right? So it gave it went up to so much of extent wherein it actually gave us serious jitters in terms of the usability of the language itself. Okay, so that was the biggest reason, guys. There are various reasons which are written, there are various reasons which, yes, they are, but the biggest factor was that with those kind of languages which are piggy banking on altogether on JVM, they started taking a great market share altogether, right? And then those are the things. So I think you can see this point here, right? Eventually many JVM based languages like Scala, Groovy, etc., they emerged. That was the main point. And also, so this was one of the things, But again, guys, uh, we are living in a different age. You talk about your laptops right now, and then people who were in IT, like from the Java 2 days or Java 1 days, if you were having your laptop in those days or your personal systems, what was the memory? What was the RAM of your systems in those days? Right? 256 MB, 512 MB. When 1 GB came, oh wow. Now we are talking about 2 GBs RAM smartphones, right? And right now the MacBook from which I'm taking this webinar, it is having 16 GB RAM altogether. This used to be a server grade configuration not many years back, right? And why is it all happening? Because we are living in the age of so-called big data or huge amount of data. So the kind of, eventually your processing power is increased, but eventually this is like catch up game, right? Eventually you started solving bigger problems altogether on those machines, this thing, right? So it's always about your problems are bigger than the actual infrastructure, and that's where you keep challenging it to evolve. So right now we are talking about, we are reaching to the limit wherein it is no more possible to scale it up vertically. You basically talk about now your processing should happen in the horizontally scaled kind of infrastructure, and then eventually you're talking about having some sort of a distributed processing platform, or the parallel processing kind of frameworks. This was never the favorite playground for Java. This was never ever the favorite playground for Java, even in past also, right? So with the advent of your parallel processing algorithms and platforms, all of that, your programming paradigms, you're talking about parallel processing. So well, can that Java's model of mutating the state of an object, this creates the roadblocks altogether, right? The way you program, so that doesn't really go very well when you talk about parallel processing and those kind of share nothing architecture based kind of programs and all. This was something which was really creating the pain. And to talk about, so are we saying that Java is not able to support it? No, Java is still able to support it. Talk about MapReduce, right? If you search for MapReduce, probably the first link which you'll get is word count program written in Java, right? Am I right? I mean, you must have done it at your end without me even talking about it, right? So all of these things were there, they are supporting, but it's not natural. It is like force putting it into the language. And hence these were some other places wherein other programming languages started taking advantage, just because implementing them in Java actually becomes a serious pain altogether. And eventually many specialized languages like your Scala, you talk about R, you talk about Python, you talk about Ruby, they started gaining a big market share for these kind of applications altogether. And hence this was the place wherein either Java had to adapt itself to the relevant changes of the way programmers code, or become obsolete. Like, you must have heard about COBOL, Vision, 1970s. Go to 1970s and talk about those senior programmers, right? COBOL and Vision programmers were like most highly paid guys altogether. You talk about today, they are highly paid only because they are the only few ones who know their legacy systems, and then nobody cares to read or cares to study COBOL programming or Vision programming now, right? So that's where either the language itself will lose the relevance altogether. So that happened, and eventually Java had to evolve altogether, right? So yes, I'm getting some nice comments also while I'm talking. So somebody is telling LIC uses COBOL. Well, there are where so many, LIC is just an Indian example. There are so many US based huge companies which are using COBOL, Vision, and their entire businesses are running on it. Okay. And then there is another business which is being developed on the top of it, which says that we'll migrate it to the big data jobs. Believe me. Okay, I personally know those kind of projects which are going on. So anyway, that's a different direction. But yes, coming back to the intention of this webinar. These were the main reasons to regain the relevance in between the programmers of a certain area. Java had to embrace these changes, and they are the main factors of Java 8. Guys, the release Java 8, this is the last point, but it is not the least. I am actually going to read this line. This release has the biggest footprint in the language functionality change. This is the one. There are other which have happened in terms of the way you program or the way you call an API or something else. Nothing has touched the behavior of Java from day one up to this release as much as this particular release has done, and hence is the reason of launching a separate course on Java 8. And wherein, so before I come to putting it all together, of course I feel this is the right time wherein at least I can just tell you a bit that I'm not going even into the curriculum and all. It's all available on website and you can always see whether it is relevant to you or not. But again, the focus and the approach. So I have designed this entire thing for Java 8 in this, and hence I wanted to take the first webinar to personally at least tell you what exactly is the thought process. The thought process here is we are not going to learn or teach Java here. It's not about that. It's all about the course which is for the professionals who already work in Java, who already are working in it, and probably they might have to be in the relevant fields wherein they have to touch with kind of some sort of parallel processing kind of cases, or some sort of so all, or functional programming kind of requirements and all, and you're finding this difficult. At that place we are right now talking about. So the way we approach the course is we assume that you already know Java. What we do is we always do the comparative analysis. We say, let's say this is the problem statement, and we always start with it. Okay, we always start with a problem statement, and then we say, okay, let's solve it conventionally the way you know. Okay, and then people, I mean, it's more of an interactive thing wherein people share their views, share their solutions, and all, and that is the place wherein we say this is how it is solved in Java 8. And that's where you come to know, okay, this is the game changer, or this is how we are talking about implementing the things in a different way. So this is the approach which we take for, it's a very short course of, and hence we have kept the course also very short, only 2 weeks, 4 classes altogether, because we are just talking about the delta. We are not talking about starting from the scratch. So wanted to make sure that all of you understand that a kind of prerequisite and the intention behind this entire course. So putting it all together, I'm not putting it again all together here in terms of, like, I've already spent good enough time here. So you have gone through the changes earlier, and this is not the last change as well. But yes, in terms of all of these changes will help you to code easily, rather easily I would say, for the scenarios which are not really very well supported by Java up to now, up to Java 7. And now hence I'm just coming to the few of the topics. Okay, this is says 1 2 3 to 5. There are, it just mentions 5 features. There are like interconnected features which come along with it. So each of them, you can think of that they are an entire module in themselves. Okay, so the biggest feature is lambdas. Okay, so lambdas are like, again, I'm not going much into the detail because time does not permit me right now, but coming to at least a very quick introduction of lambda. So lambdas are like your anonymous programs. In Java, can you even write a single line of code if it does not belong to a class or a method? You cannot. You simply cannot write any line of code, right? This is something which is definitely not supported. I mean, in Java it has to be the part of a method always, till the time your code doesn't make any sense at all, right? Here with lambdas you can write anonymous code which is not the part of any method at all. Okay, so you might just be wondering that this guy is telling that you can write an anonymous code. What is a big deal about it? How is it going to solve the things? uh, the time is too short to discuss about that, but I will give you a very quick hint at the end of this slide, and we'll try to connect some of the dots with the hands-on also to give you some idea how powerful they are in changing your programming style itself. So lambdas. Streams. I think some minutes back, some slides back, I was telling you that streams and lambdas have changed the programming paradigm completely. Streams, as I just told you, that reading the data from a stream, processing it, that style, that output of one becomes the output of others, and then creating the pipeline altogether, right? So when you combine lambdas with the stream, they create super short, super concise code altogether. Okay, functional interfaces, I will not go much into those details because functional interfaces are actually one small part of lambdas. Okay, so we will talk about that when we'll talk about behavioral parameterization in actually the classes there. But let me just tell you, they are a special kind of interfaces which are kind of your marker interfaces altogether, which says that your interface can have only and only one abstract method. But that is something which creates a big deal when you try to write your codes in the form of streams altogether. So they will help you quite a lot. But there is one thing which is kind of missing in this slide, but I would like to tell, and I would like to ask the class, sorry, entire audience here, that an interface. So what is the definition of interface for you? Or rather than that, let me just rephrase my question. Can your interface have any concrete methods? So my question, just in case if you have missed my question is very simple here. With your knowledge as of now in terms of Java, right? What do you think? Can your interfaces have the concrete methods, the actual methods implementations or not? With Java 8, things have changed. I will just keep it at that. I'm sure there it will raise some of the questions in your mind. Ah, so is Vishal saying that can you have the actual methods in interfaces? Yes, guys, I'm saying exactly that. Now you can define actual methods in interfaces. Now you might be thinking another question, just like being any Java developer, then what is the difference between an abstract class and an interface now? Am I right? So these kind of questions will come, and hence things have changed a bit, right? So if you ask this question in an interview and somebody comes back and says, no sir, no ma'am, actually there can be the methods, there can be methods in interfaces. So now that question itself has changed. Does it give you some idea, right? Aditya, Jubin, Geeta, others, Ravi, others, right? I'm just taking some random names here, like people. But yes, it must be giving you the idea that your paradigm, your world, the way you know Java, the behavior which you think Java does itself is going to change drastically with this change. Am I right or wrong? Right? So this is just one case altogether. Okay, with lambdas, with these kind of changes, uh, you know things actually, and they have changed for a good reason. So time doesn't allow, but yes, in the actual course these will be the lines on which we'll be discussing that, how is it going to help you, or where exactly it is going to uh, help you in writing your programs in a better way. So this is the change of the interface itself. So this default methods basically, oh, actually default method was about the interface, function interfaces, and then new date and time API altogether. If you talk about new date and time API, I think I just give you the idea about that. Most of your Joda time type of things have been introduced, or those capabilities are now available with the date and time API. Okay, the native date and time API. Great. Well, as I promised you that I will be doing a hands-on, I will definitely do the hands-on, but before that I want to now actually I want to put the things together to make some sense out of it. Guys, most of you would have heard about lambda and stream from me, but probably not many of you would have made a concrete understanding that why how exactly they combined together are going to help you. Okay, So let me just tell you a few things altogether. I was telling you, right, that Java now supports functional programming, right? That is something which I discussed with you, right? What are the two most important paradigms of functional programming which make it different than your object oriented programming? So again, when I'm talking about the paradigms of functional programming, they are irrespective of any languages. Any language which has to support the functional programming thing, they have to support these kind of paradigms up to the extent they can do. Okay, so I'm not saying Java stays true to it, but Java tries to come to these paradigm points as much as possible. So the first thing first is, wherein Java scores perfectly well, is the functional any functional programming language will treat its functions, or if you call as methods, as you call it in Java, as the first class citizens. They are the first class citizens. Okay, this is a very big word which I am using. Okay, so what do you mean by the first class citizens? The first class citizens means your variables, right? When you, how do you treat your variables? You can initialize the variables, you can assign the variable to the other variable, you can operate the variables, you can pass them to the different functions as the arguments. Am I right? This is what you do with variables altogether. And that exactly is something which should be, your functions also should be treated in the same way. Now can you think that how is your world changing now? Now you are talking about, if you are going to give the same treatment to the functions, then you are, you can create new functions, you can assign them to the other variables, or you can pass them as arguments. Am I right? Now is this something, exactly, functions can be the arguments now. That exactly is something which you will see Geeta and others very soon in this thing, right? Just like in JavaScript, yes, you can say so, exactly, Sudhanshu and others. But now now Sudhanshu and others who were talking about passing functions around and all, now do you understand why I was saying that it is just the outcome? The paradigm is the same treatment as variables, right? Passing them as an argument to the function is just one of the side effects. Is everybody clear about it? I hope everybody should be, right? So this is just one part of it. Then let us talk about the second thing, right? The second thing is about the second paradigm is, actually your functions cannot have any side effect. Your functions cannot have any side effect. Simply, when I say there can't be any side effect, it's like you eventually are talking about the immutable data structures. So for the given input, you cannot modify your input at all. You can only consume it and you can create a new output. Okay, you cannot really modify your input. And guys, I don't need to remind you how many times do you modify the input map which comes as a parameter? How many times do you modify the input list which comes to you as a parameter? How many times do you modify the data structures, or any collection for that matter? Am I right, guys? So this is something which, this is the place wherein Java leaves it up to you. Okay, Java leaves it up to you, but you will be forced to actually program in the way, that functional way, wherein it will be discouraged. And hence, in the best way to discourage them is to create immutable structures. Am I right? The best way to discourage them is to create the immutable data structures. And can somebody recall that I was talking about immutable date and time API? I hope so. I will leave it up to you, because you guys are smart enough to do that remaining thing, connecting the dots and all, right? Um, that's the best which I can give you in terms of the context within this 1 hour kind of thing. So you can clearly see that things have changed quite a lot, right? So are we good, guys? These are few of the things which have, like, so functional programming style itself has driven all of these changes. Hands-on. Okay, hands-on is, of course, I'm going to show it to you, but it will be like very small, very short sort of a thing. And guys, let me just tell you, I mean, code is not important here. The intention is, okay? There is an intention which is really important here. Okay, because code, in fact, I discuss the very same kind of code in the classes also. I always try to keep the code simple and try to keep the concept clear. That's what is the whole idea. So guys, in order to discuss that, I would just say, let's say you have a simple scenario, okay? Uh, a game of bowling alley, right? You just have to design a simple program which filters. So some a player comes and says, can you just filter the red color ball for me, right? Or can you just filter a green color ball for me, or something like that, right? So you now this is the thing, right? And let's say it's not a player, it's some sort of a system which basically says that, just give this much. So if somebody just says this, then what is your first reaction? Your first reaction is to write a program like it is written right now. Okay, so this is a program. So there is an entity called ball which I created, and that has just two things. Okay, it has got a size, and sorry, it has got a weight and it has got a color altogether, right? And what really happens is, I am just creating, as you can see that in the public static void main itself, I'm just creating three entities or three instances: 80 blue and whatever, 155 green and 120 red and all. And then the whole idea is, if you have to write a simple method, probably you will just write this kind of method altogether, right? Which will take an inventory, right? And then you will iterate through it, and then while iterating, whatever elements are going through, or whatever elements are supporting this kind of criteria, you will uh, you will simply just filter them through, right? Jobin, I'm actually showing the code. I'm not sure whether you are not able to see my machine or. Okay, so as I was just saying that probably you would write a simple method which takes a collection of ball or list of the balls as an input, and then probably in you that's the natural approach wherein you will iterate through that inventory, you will apply your filter, and whatever, once you are done with that iteration thing, then you will just return the result. Am I right? This is the simplest way of coding. No complexity here, nothing. Now this is a case wherein we just kind of uh, you know uh, filtered a thing. Now you know what is the constant thing in the software industry, and the only constant is the change. Right? The only constant is the change in the requirement. So now somebody comes back and says, oh great, that you have actually kind of filtered this thing, but I want a generic utility wherein I'll just tell you that I just don't want the green color. Tomorrow I might want a red color ball, or some other ball or something else. Then um, then what? So then your usual intention is something like your second take.java, which I have just created here. Probably in the second take, what you will do is you will take the inventory as well as color as the parameter, right? Simplest thing. Wherever you are hard coding, basically you are taken to the color, and now whenever a color is passed, right, based on whatever color you are passing, you will automatically give this. So this is the second refactoring altogether.